Well, previous lessons we consider such data type as pointer, and we discuss about connection between arrays and pointers. Let me briefly repeat that when we declare an array, the name of the array, let me skip, yes, the name of the array can be considered as a pointer to this array. So when we declare an array like this, int mass 4, array with 4 numbers, the name of the array mass is a pointer, and we can apply all the operations that we can apply to pointer. We can apply it to the identifier that corresponds to the name of the array. For example, we can apply operation star, that means getting the access. For the first element, we can apply operation ampersand, that means getting the address of the first element. And for the name of the array, we can apply operation, we can apply addition to the addition that apply to pointers. Name of the array plus I means moving pointer I position to the right. Name of the array minus I means moving pointer I positions to the left. We consider these features on previous lesson. I show you this example. And when we declare array A with size 10, after that I can get access to the elements of the array on 2 ways. First way is usual. I can write A and index in brackets this way. And the second way is not usual, but sometimes it's used. A plus I means moving pointer to the I positions to the right, and star means getting the access to the cell to which this pointer points. These two notations are completely the same, and in terms of time these two notations are equals. Moreover, let me show you one more feature of the arrays. Let me comment all of this code, and let me write the following loop. Let me output such values. What's written here? A AI is the element number I in the array A. And this operation means getting the address of this element. It means that if I have 10 elements in the array, this is the cell number I. Suppose that some number is written here in the cell, and ampersand, operation ampersand, gets the address of this cell. So this loop outputs to the screen all of the addresses of all of the cells in this array. Let's look to the result. We should see 10 hexadecimal numbers on the screen. 10 hexadecimal numbers. Do you remember what is the size of the integer number in bytes?
4, right?
4 bytes.
Bytes, yeah.
Yes. For each integer, compiler allocates 4 bytes. And if you look to these numbers, you will see that these numbers differs by 4. 40, 44, 48, and the next number is 4C, where C means hexadecimal number 12. Then 5, 0, 5, 4, 5, 8, 5C, and so on. So you will see the addresses of the cell, of the cells of the array. Yeah? And of course, each of these cells has some value. If you write something, if you assign some value to this cell. Well, now, let's consider such construction as dynamic arrays. What does it mean? Up to now, we consider only the arrays of the fixed size. The size of the array must be a constant. This is true for the version of C++ implemented in Microsoft Visual Studio. If you use some other compiler, in this case, it's not true, but because C++ slightly differs from compiler to compiler. In Visual Studio, this is true, that you can declare an array only of the fixed size, only of the constant size. And in this case, if you need to change the size of the array, you should manually change the value of the constant in the program and recompile your program. It's not very convenient, because if you have a very large program, you should recompile it every time that when you decide to change the size of the array. So in this example, the size of the array is declared here, const in size. If I delete the keyword const, compiler outputs the mistake, the error. This variable this identifier must be constant. But how to change the size of the array? The answer is dynamic arrays. There is a possibility to work with arrays, sizes of which are not defined in advance, but can be set in the course of program execution. Such arrays are called dynamic arrays. The first type of the arrays is called static, and the second type is called dynamic. So dynamic array, you can change the size. You can change the size of the array in the course of program execution.
So let's say you declared an array of 10 elements.
Mm-hmm.
So it means that as soon as you declare, the compiler will assign like 10 cells already, even though you use like 4.
Please repeat your question. When I declare the array of 10 elements, compiler allocates the memory only for 10.
For 10, yeah. So I'm trying to say it might be wasteful, like when you want to use only 4 cells. That means
yes, yes, it will be empty. It will be empty in this case. But when you decide to change this size, you should manually delete. You should manually change the size and restart, recompile your program. Recompile your program every time when you change the size.
We have compile time and runtime. So, what is the difference between this? I know what is the compile time, what happens compilation for code up to the runtime. But what is the best way to declaration for size of array?
Usually, it depends on the problem that you solve. I cannot say that dynamic array is the best or static arrays are better than dynamic. It depends on the problem. If you solve the problem when you know in advance that the size of the array is 10 and only 10, the static array is a good decision. But when you solve the problem when the size of the array can be changed, you cannot use static arrays. You should use dynamic. So it depends on the problem. In some problems, these sizes are fixed. For example, if you are working with some, for example, if you solve the problem in the field of image processing, and if you are working with pixels, so in this case you have a predefined number of pixels in image, and only this number of pixels.
What about the speed? Say static array are allocated memory at compile time, and the dynamic array are allocated
in
the
runtime. Yes.
What is the more speed?
More speed? Of course. Again, can I say that? I cannot say you're the answer. It depends on the problem. Suppose that you solve the problem that process very large area.
I mean compile time and runtime is not equal to the speed.
When you are working with arrays of large size, usually these arrays are allocated in the way of dynamic arrays. And when the arrays are small, in this case, these arrays are static because when compiler allocates the memory during compilation of the program, this memory is fixed, and when you allocate this amount of memory is fixed when the program is running. Well, there are several types of memory, and there is such type of memory that's called dynamic. This memory can be requested in the course of program execution and can be released, can be returned back. Using this memory, programmer can allocate the memory for so-called dynamic objects. These objects appear when programmer allocates the memory and disappear when the memory is released. And for interaction with dynamic memory, two special operations are used: new and delete. New allocates the memory, and delete released the memory. When you are going to create an object dynamically, you should use new. And when you are going to delete this object, release the memory, you should use delete. And a good example is dynamic arrays. How the operator new works. Here it's you can see two simple examples. These examples are more or less the same. Let me explain example number 2. In example number 2, I declare two variables. First variable is integer number, and the second variable is a pointer to integer. N as integer, and the second variable mass is a pointer. As ordinary variables, n and mass are undefined. So n contains a random number and mass contains some random pointer, a random address. These variables are not defined. Suppose somewhere in the program I assign a value for the variable n. For example, by means of cin operation. After cin, n will have some value. And after that, I can write the following line. Mass equals to new int n. Operation new allocates the memory for n elements of the type int. Let me write it here in presentation or in Visual Studio or here just in it's better. Oh. Okay, I just place it here. New, the general form of new. New. After that, you should write type and in brackets we can write the size. This size is optional parameter, and if this size is omitted, it's suppose that size equals to 1. You allocate the memory for one object of this type. Here I can use any type. For example, int or float or any data type. And the main feature is that size may be variable. This size may be not a constant, but a variable. And this, suppose the type, some type, and this operator new returns the pointer. I denote it like this. It returns the pointer that points to this type. So when you write, for example, new int 5, it means that somewhere inside computer memory it will be allocated 5 cells, and the result of this operation will be the pointer that points to their first cell. And if I store this pointer here in the variable mass, after that I can use mass as the name of the array, because name of the array is a pointer to the first position. This is a main feature. When you declare the static array, you can use the name of the array as a pointer, and vice versa. If you declare the pointer and after that you allocate the memory, you can use the name of the pointer as the name of the array. And when you finish your work, you should write delete mass to delete the memory. I think it's better to show you some example in Visual Studio. Well, let me use the same identifier size, but now size will be a variable, not a constant. In this case, this construction becomes wrong, but I can create a pointer A. In this case, the name of the array is a pointer, and vice versa. The pointer can be interpreted as the name of the array. Now this pointer points to nothing. What should I do? I should specify the concrete size. For example, by means of cin. Cin size. After that, I should allocate the memory. A equals to new int size. And after that, I can work with this array with the array A as usual. For example, I uncomment this. Let's assign, for example, I. Okay. And here let's output to the screen. Well, what I done here? I just assign the values 0, 1, 2, 3, 4, 5 to the array A and output these values to the screen. Sorry?
You can use pointer from what elements of array, like previous.
Yes, you can use. Yes. And in the end of the program, I should delete the memory. I should release it by means of delete. Delete A. Well, let's check this program. The program asks me to input the size of the array. Let it be 5. And we see 5 elements. After that, I can just start this program without recompilation and enter another size, 8, and we see 8 elements. 100 elements. So I don't recompile this program, I just restart it without recompilation. This is the two main lines, this one and this one. Well, now let me show you some features. For example, suppose that you write const int size and a size. What does it mean? It means that I use the array of the fixed size 4. But this line, the last, where is it? Yes, the last line. The last line will be correct from the point of view of compiler. But if I try to run this program, I'll see the mistake, because here, this line, I try to delete static array. I cannot delete static array. I can delete only dynamic arrays. But compiler doesn't check what array I try to delete, static or dynamic. It should be checked by programmer. Like compiler doesn't check the bounds of the array, compiler doesn't check their pointers that points to the array. Well, this is the first feature. Okay, let me back to the situation where I declare a pointer. Now A is dynamic array, and this operation is correct. But suppose that I forget to write new. What happens? It means that I declare a pointer, but I don't allocate the memory. And if I compile this program, compiler tells me Okay, I can initialize it with null. It's a special constant that declares null pointer, no memory. But suppose that I forget to assign, forget to call a new. What happens? Compiler tells me, okay, the program is correct, but when I try to run it, the program finished with a error code. It doesn't work because here I try to get access to the array without memory. So the rule is very simple. If you are going to use dynamic arrays, don't forget to write new. And if you write new, don't forget to write delete. Two simple rules. Now this program is correct, and we can work with a dynamic array on the usual way.
So when you are declaring dynamic array, you should always declare a pointer.
Always, yes, always. Dynamic array means pointer. It means that I should declare a pointer and after that allocate a memory. More questions?
No, sir.
No questions. Well, now only 8 students are here. 6 students online. For one is you. Five students online and 2 students here. But this topic is very important. I think that's why we stop now. And next time, in the beginning of the lesson, I briefly consider this topic again, and after that, maybe we consider two-dimensional arrays or something like this. So some features with arrays, some features with dynamic arrays. Well, to understand how it works, try to use dynamic array in your program. So it's very simple. You should write here this line. After that, you should assign the size. You can assign this size not only by means of cin, you can just assign it by means assignment operation, any operation that changes the value of the size. And after that, allocate a memory. So three steps: pointer, then size, and memory. Allocation, memory allocation. After that, we work with array on usual way, and when the array becomes unnecessary, you should deallocate the memory by means of delete. Well, let me repeat once again. These features of getting the access to the cells using pointer is used not often, just in some few cases. But this feature of the dynamic arrays is used very, very often in 99% of the programs that operates with arrays. We use dynamic arrays.
So the only way to get the only way to declare a dynamic array is to use a pointer, right?
Yes, yes, there is an only way. Only way with some remark. If we use standard version of C++. In Visual Studio, C++ is standard. But in some other development environments, like code blocks or some maybe online compilers, they use a non-standard version of C++, and on using that development environments, you can declare arrays with variable size without pointers. But in Visual Studio, there is only one way. Moreover, in under Linux, this way is also the only one way. If you will use some compilers like GCC or any other compiler.
I'm using code blocks with GCC compiler, so it's standard or what?
I don't know, because I use GCC not very often, just from time to time.
Not idea. Compiler, viewer. Yes, GCC.
Mm-hmm. Well, I think that GCC supports only. I think GCC supports only standard version of C++. Well, any questions about pointers and about dynamic memory?
No, sir.
No. Well, if you don't have any questions, I think we finish right now. We meet next week. I hope it will be more students here, not only 2. And we briefly, maybe just 10-15 minutes, repeat the main points related with dynamic arrays. And after that, I think we consider two-dimensional. We discuss about two-dimensional arrays. And week after week, we start to consider functions.
Okay,
well, let me stop sharing and stop recording. If you